What's up everybody, my name is Moss Norman and today's video is an OMSCS course guide on Introduction to Graduate Algorithms. I'm going to do a high-level overview of the course and the material that's covered in the course, and then I'm also going to give you some tips on how to survive and prep for the course. The first algorithms course in the OMSCS program was CCA, Computability, Complexity, and Algorithms, and then it was updated to a new course which was Graduate Algorithms, and that took the place of CCA. Graduate Algorithms is known to be a very difficult course. It's the 7th highest rated course on the OMS Central website in terms of difficulty. And in addition to being one of the most difficult courses in the program, it is a required course for 3 out of the 4 specializations that you can take in the OMSCS program. The only specialization in the OMSCS program that you can graduate in that doesn't require graduate algorithms is interactive intelligence. All of the other specializations require that you take graduate algorithms in order to graduate from the OMSCS program. So the course has gained a reputation as being kind of the last barrier to for an OMSCS student to graduate, and it sometimes becomes a blocker for a lot of students who are not prepared for the course and aren't able to make it through the course with a passing grade. I'm here to tell you that although the course is a very difficult course, and it was by far the most stressful course that I took in the program, you can make it through the course. I made it through the course. I made I think a low or a mid B in the course, and I had 0 algorithm experience prior to taking the course. Not in my job, not in my undergraduate studies. My undergraduate studies, it was not even a computer science degree, it was an English degree. So if I can make it through the course, you can definitely make it through the course. You just need to know how to prepare for the course and what to do during the course in order to be successful. And hopefully the information that I give you in this video will help you be successful in the course. First, let's go over the course material and what is covered in graduate algorithms. Although the course changes from semester to semester, like all of the OMSCS courses, I'm going to try and target the material that stays fairly static between semesters. So the first thing that you study in the course is dynamic programming, followed by divide and conquer algorithms, then graph algorithms, linear programming after graph algorithms, and then you study NP completeness and NP reductions. One thing that threw me off about the course when I first started was the format of the answers that you have to use when you're answering a particular problem for dynamic programming, divide and conquer, graph algorithms, and NP reduction problems. The first problem structure that I want to cover is dynamic programming problems. When you provide an answer to a dynamic programming problem in graduate algorithms, there are 4 parts to the answer. The first part is defining the subproblem. The second part is defining what's known as a recurrence relation. The third part is providing pseudocode for the algorithm. And then the fourth part is justifying and defining a time complexity for your algorithm. In the video description, I've linked to a sample answer for a dynamic programming problem pulled from the course textbook. And it shows you what the structure of a dynamic programming problem is and what is expected for you to follow when you take the course and you're answering dynamic programming problems on the exams and the homework. The next set of problem structures that I want to cover are mostly the same. There are nuances that I'm not going to cover in this video because they get too detailed into how to solve each type of problem. But in general, divide and conquer, graph algorithms, and NP reductions are all expected to be answered in essay format. So you do not provide pseudocode when providing answers to problems on the homework and the exams in the graduate algorithms course. Again, I linked to a sample answer for an NP reduction in the video description below, and there's a set of problems in the link, all of which come from the course textbook. By the way, the course textbook, I've also provided a link below in the video description. The primary course textbook that's used in graduate algorithms is called Algorithms, and it's by Dasgupta, Papadimitriou, and Vazirani. It's commonly referred to by the students and by the faculty as DPV. Now some tips for how to be successful in the course. Tip number 1. At the back of each chapter in the course textbook, DPV, there are a set of problems that are related to the material in that chapter. Make sure that you do every single practice problem at the back of each chapter. This can be kind of challenging because you're not provided with an official solution set to the problems. So what you have to do in order to supplement that is you can Google search DPV problems online. You can literally take a problem ID like 2.12 and just type in DPV 2.12 on Google, and you'll get some search results that provide you with solutions to that DPV problem. Now there is one caveat. The solutions that you find on the internet are not always correct. So make sure when you're looking for an answer to a particular DPV problem that you find maybe like 1 or 2 other copies of a particular answer to verify that the answer is correct, because sometimes you'll find 2 or 3 links for a particular problem and they won't match up. The answers won't match up. So you got to kind of work out which one is correct and which one isn't, and that'll require some thinking. But typically when you see those solutions, they will give you enough hints to actually work the problem out on your own. The exams typically pull from either the homework or they pull from problems that are found in the DPV textbook. So it's incredibly important that you do all of the DPV problems in the chapters that are covered in the course. The homeworks are also a really good indication of what will be covered on the exam. So let the homework problems kind of guide your focus on where to study the most, because homework problems are almost always giving you a hint as to what's going to be on the exam. The next tip is to be an active participant in the Piazza and Slack forums. A lot of conversation happens in both Piazza and Slack between students, and then also between students and the faculty and the TAs. And the TAs will really help clarify solutions to problems like homework problems and exam problems and stuff like that. So make sure that you're an active participant, because that'll help improve your understanding of the course material. The next tip I have is very important. It's to practice setting up your exam environment multiple times prior to an exam in graduate algorithms. Out of all of the exams that I've taken in the OMSCS program, there is no exam more stressful that I've taken than the exams in the graduate algorithms course, primarily because of the exam requirements. The exams are handwritten or they're typed out, depending on what your preference is, if you want to type them out in like a Word document or something like that. And there's a lot of requirements around how your testing environment's set up, like what's on your desk. You have to make sure that your camera's working. If you're writing your exam, you have to make sure that you have a scanning app on your phone that you can use. You have to make sure that you're keeping track of time. It's an incredibly stressful exam. And the instructors give you a practice exam that you can use to test out your environment, test out the utilities that you're going to be using, the pencils or pens that you're going to be using on the exam, the software that you'll be using on the exam, and make sure that your testing environment is solid. So be sure to do those practice exams. I'm telling you, the last thing that you want is you're writing your exam, you get done and you go to scan it, and you're using a scanner app that's like a freemium app, and right as you go to scan, it starts playing like an ad or something on the app. You do not want something like that to happen. Lastly, make sure that you supplement the course lectures and the course material with external resources. And supplement your conversations over Slack and Piazza with external resources. And by that I mean, you're probably going to get a high level overview of the algorithms in the course from the course lectures, but you're going to need to go into more depth and to really understand the problems and the algorithms. So if you're struggling with a problem, make sure you just go on YouTube, search for that problem. I guarantee you there'll be like 5 videos with just fantastic explanations walking you through on how to complete a particular algorithm. That's all for this video. I hope that you found it informational. If you liked it, please consider throwing a like on the video and subscribing to the channel for more videos. And if you have any questions or feedback, please be sure to leave them below in the comments. Thank you.